Yes. So this is our in-game profiler. Conceptually, each row represents a different thread over time. And you can see that on each thread, we schedule different work to be run. So like here we see during this period of time, we were running something called a heartbeat. Here we were like doing garbage collection for Lua. Here we were doing some processing for sound. And here we're doing some processing for render. Above here, we see worker run job. So what's going on here is basically the way that we structure work in the engine is we have these classes called jobs. Each job object registers itself with a task scheduler, and then the task scheduler guarantees that each job gets a turn to run every frame. So that like, so there'll be one rendering job, there'll be like a sound job, there'll be like a Lua GC. Well, it's interesting, Lua GC explicit job, I forgot about that. Like this is physical simulation, like there's nothing happening here, so like physics just does nothing. And there's like this heartbeat job. The primary purpose of the heartbeat job is to be a hook for scripts, so that scripts can say, okay, a new frame has to come in, let me do an update to my game state. So yeah, so so coming back to the task scheduler arbiter, so a data model acts as a what I'll call sort of like a concurrency domain. What we guarantee is that for any one data model, only one job is running at a time associated with that specific data model. So like while this heartbeat is running, okay, so this is a little bit, so this is on the main thread. This is doing an asynchronous render. So this work is not associated with a specific data model, so it can run in parallel with anything. But we see that there's like no like work mutating the data model while the heartbeat is running. And that's sort of the core guarantee of the task scheduler is that like I'm saying this backwards. So the data model is an arbiter. The arbiter is basically sort of a concurrency domain that aggregates a bunch of jobs like the render job and the Lua GC job and the heartbeat job. And we guarantee that inside that concurrency domain, they all happen serially. But if you happen to have two data models in your process, then you don't have any guarantees about those running in parallel with each other. And that's where arbiter comes in. So basically every job has a pointer to its arbiter, and then jobs can run in parallel if their arbiters are different, but they can't run in parallel if their arbiter is the same. So let me, inside Studio, we actually can see an example of this. So when in Studio you do play solo, what actually happens under the hood is we have one data model in place that's acting as the server, and another data model in the same process acting as the game client. And if we pause the profiling, what we should be able to see is work happening for both data models in parallel threads. Yeah, so we can see here that in this thread, we're doing simulation for data model A, and in this thread, we're doing simulation for data model B, and it's happening in parallel. And the reason this can happen is because these jobs are tagged with the arbiter for the first data model, for the data model acting as like maybe this is the client because it has a render step, and this one is the data model is tagged as this simulation job is tagged with the arbiter for the server, so it can run in parallel because it's for a different arbiter.